This video lecture is going to cover just a few of the basic setup structures for game theory in the world of economics. But first, what I'm going to do is just introduce the concept of game theory within the world of economics. Often in economics, we use general equilibrium reasoning where we have large numbers of firms or consumers, etc., and outcomes don't rely on strategy. Think of your perfect competition model where you have a large number of firms. There's not a lot of strategic behavior happening there. You're taking things like price as given and quantities as given based on your cost structures. There's not a lot of strategy that we can rely on. Game theory is looking at these situations where strategy could matter a great deal more. When we're looking at the strategic behavior of individuals or firms or whatever we're working with in game theory, you have to realize that we're still staying within the same basic setup of standard economics. The idea that basically people maximize utility functions, our firms maximize their payoffs, things like that, is still going to be there. We follow the incentive structure. The slight change to this is that game theorists often use the word payoffs instead of utility. There's a little bit of a difference here. The concept is basically the same though. Given a choice of payoffs, the agents pick the largest payoff. And what this does is payoffs are usually interpreted as von Neumann-Morgenstern utilities, which what this does for us is this allows us to sidestep issues of risk aversion. So you could have a game where the highest payoff seems like a really good choice, but it's really a risky strategy to get there, and a risk-averse person might not play that strategy. What we're doing here is we're saying, no, these payoffs already basically include all of that risk aversion, so you don't have to worry about that. A payoff of 5 is better than a payoff of 4. A payoff of 1,000 is better than a payoff of 1. We've already calculated in the utility from the risk aversion into that payoff, essentially. So the first game theory structure that we're going to look at is going to be a normal payoff matrix that you've probably seen before, and this is a normal form game. Here's the normal form payoff matrix. You see you have player B, and player B in this game has two options, to play left or to play right. And then you have player A with two options, one to play up and one to play down. So if player A plays up, we will be in this row. If player A plays down, we will be in the bottom row. If player B plays left, we will be in the left column. If player B plays right, we will be in the right column. What we have here is player A's payoffs are listed first. So in this outcome, if we played up and left, player A would get a payoff of 10, and player B would get a payoff of 0. The same is true for the rest of the matrix. So if we were in the down row and the right column, player A would get a payoff of 10 and player B would get a payoff of 0. Or if we were in the left column and the down row, player A would get a payoff of 0 and player B would get a payoff of 10. That's how you interpret the basic payoff matrix of a normal form game. You see what does player A choose, and if he chooses, let's say, up, we are in this row. And you say, what does player B choose, and let's say he chooses right, we are in this column. With that situation, we would end up in this quadrant here of the up-right selection where we have a payoff to player A of 0 and B of 10. The next form we're going to look at is the extensive form, which allows us to have sequential games where one mover acts after another mover. This allows us to do a number of different things, like see each decision point along the way for each mover in a sequential game, but it also allows us the representation of incomplete information and chance events that are sometimes talked about as moves by nature in game theory. We're going to talk about basic sequential games so we can see the actions of one individual or one agent after another agent. Extensive form games are often shown using a decision tree. Here we have player 1 choosing first, and they get to choose between U and D. So you see the choice set for player 1. They can choose one of two nodes. We could have 3, 4, 5, whatever nodes or choices. The choice set for them could be much larger than just two options. But we just have two options here, and then what happens is after player 1 chooses, then player 2 decides what they're going to choose, U prime or D prime, U prime or D prime. Right? And what that does is this takes us to our final payoffs. Payoff for player 1 listed first, and the payoff for player 2 listed second. So we get player 1 acting first, selecting U or D, and then player 2 selecting second, picking U prime or D prime, and U prime or D prime, depending on what the first player's strategy was. This is basically a decision tree to show us this extensive form, which allows us to see sequential behavior, sequential acts.